Hey guys, it's MJ, the student actuary, and in this video we're going to be looking at artificial intelligence and American football. And the reason being is that sports involves a certain element of chance, but it's not like gambling, you pull that slot machine and you just hope for the best. When it comes to sport, your choices can influence your chances. And whenever there's chances, they're going to be actuaries. So we've already, made like a little model on cricket, and my friend's done a model on soccer results. So I thought, why not make a model on American football? And there's two main reasons why you'd want to make a model. The first is so that you can win at betting, make lots of money. Or the more interesting and the more enjoyable reason is to make games, and that's what we're going to be doing with this American football model. We're going to use it to make a game. So what we're going to do is we're going to start off very simply, and we're then going to build on complexity as time goes by. So we're going to start simple. And what is more simple than rock, paper, scissors? So think of rock, paper, scissors, American football, and you get run, throw, kick. We do add on another layer, so when you run or whether you throw, you can either do it safe, normal, or risky, just to add just a little bit of complexity. But remember, this is still a vast simplification of American football because it is much more complicated. But remember, we want to start with a simple model and then build on as we learn or at a later stage. So let me show you the game mechanics. What will happen is you'll make a choice, your opponent will make a choice. This will then go to a distribution matrix, and the outcome will have various probability weightings. So let me give you a quick little example. Let's say, for instance, I chose to run wide and my opponent chose to pass, defend, long. What this means is, as you can see, it's highlighted in yellow, the probability of me making a big loss or a small loss or nothing is 0. I've got a high probability of making a small gain, a big gain, and a very small chance of making a mega gain. If you go back to that previous distribution, you'll see that by going long, you had a much greater chance of making a mega gain, but then you could also fumble type of thing. So what we're basically making is the yards gained is the random variable. So, and it basically comes down to this. If you choose to throw, that's kind of risky. There's a little bit of volatility in it. It's more of a fat tail distribution. Whereas whether you choose to run, it's more of a thin tail. It's a safer, but you're not going to make as many yards. So this is just an assumption I am making with regards to American football. This is how the app is going to look. We've actually got a current version out. It's not on any of the app stores, just that I've been playing around with my friend who I've been making it with. And we can play against each other, and it goes to all of this, and it's really cool. But in order for us to play against each other, we have to connect to the Google Play Store, and we've realized that both of us have to be on at the same time in order to play the game. So I thought, why not make an artificial intelligence, for the computer to play against us? And I thought, let's bring in some of the actuarial science that I've learned. So we're going to be using a Bayesian principle, which means that the probability weightings are going to evolve and the computer is going to learn. So if we have a quick little look at the mathematics, for those of you familiar with Bayesian statistics, we will have a posterior, and we'll have a prior, and we'll have the evidence. So what will happen is I'll take real American football statistics, and this will become the prior. Depending on how I play, the computer will use that as the evidence, and along with the prior, it will then create the posterior distribution, which it will then use to make its choices against me. So what it's going to be doing, it's basically going to be counting the decisions I make, creating a bit of a frequency diagram on what I'm doing at various states on the field. So if I'm very close to my opponent's end zone and I always seem to run at that stage, the computer's going to learn that and factor that in when it makes this decision. Whereas if I'm throwing when I'm in the middle of the field, it's also going to take that into account. So the idea is that if I keep playing the exact same way, the computer's going to learn my strategy and I'm going to lose. Now, when it comes to artificial intelligence or machine learning or whatever you want to call it, there's three key ideas. The first is the learning rate, and this is how quickly does the system learn. So what emphasis does it put on the posterior data compared to the prior data? The more emphasis on the posterior data, that means, the more it's learning, the more it's taking in the evidence and rejecting the prior information. Then we have the discount factor. That is not to be confused like with the time value of money discount factor. This is something else. This is your system focused on short-term goals, like making as many yards as possible within that down, or is it focused on more long-term goals, like scoring points and actually winning the game? And then there are the initial conditions, which is what you set the prior data as. And this kind of gives the artificial intelligence its own personality. And we're going to see later we can maybe mix this up and create different personalities to take on each other. But let's say you play against my system and somebody else plays against the system. Each time somebody plays with the system, it's going to learn that player's behaviors. And so it's going to become a little bit unique towards that player. It's going to learn your style, whereas if somebody else plays, it's going to learn that style. So we're going to be creating, you'll have your own unique artificial intelligence that you'll be taking on. And what will be cool is if we can gather all that data. So you'll be playing online, we'll be capturing that data, and we'll create this massive library of various player strategies. And then what we do is we take all this big data and we look for patterns, and we use all the various actuarial and statistical techniques that we've learned to predict a new player strategy just from the first few plays. So if somebody, let's say the data identifies two types of strategy, a player who runs a lot compared to a player who throws a lot, just as a very simple explanation or simple example. And you come up and your first two downs, you decide to run it. Then the system might say, wow, this person is incorporating this strategy, this is how we're going to play against them. So in effect, our AI won't have to learn anymore, it would become mature and it'll be able to predict your every move. Otherwise, this is known as reaching the Nash equilibrium, for those of you interested in game theory. But that is the general idea of artificial intelligence and of the system we want to make. The more people play it, the smarter it becomes. And then, like I said, it would be a lot of fun to, get the AIs to take on each other. Have an AI with various learning rates and different discount factors to play against other AIs with a different configuration, and to see, which one is the best. And then once we have optimized our artificial intelligence, we might be able to step it up, make the system a little bit more complicated, and the ultimate goal would be possibly to replace an NFL coach. So I know that's a big dream, but it would be pretty cool if in the American Football League you have all these coaches and then one team is run by an artificial intelligence, and it will be really cool to see how it competes against the rest of them. So yeah, if you guys are studying actuarial science, you'll know that from subject CT6, you'll be learning a whole bunch of stuff around this so that you can apply it for artificial intelligence. You learn it for insurance, but the same maths can be used in machine learning. I mean, as you can see, there's decision theory, there's Bayesian statistics, there's credibility theory, there's time series, Monte Carlo simulations, all that stuff is for machine learning as well. And yeah, that's basically the aim of this project, is to take rock, paper, scissors, American football, throw in a little bit of actuarial magic and get artificial intelligence. Now, I know this is a video a little bit off what I normally do, but if you are interested in this, I will be making another video later on just with regards to rock, paper, scissors. I've made a slightly different version of the game where if scissors wins, you get 3 points, if paper wins, you get 2 points, and if rock wins, you get 1 point. And what I'm going to be doing is I want to make a video explaining how I go through the mathematics of creating an artificial intelligence for this simple game. And this is important for me because once I can do it for this simple game, I can then step it up for this American football game, which we're going to make, and it's going to be really cool. So if you're watching this a little bit later, you should be able to see a link if you click rock, paper, scissors. But if you're watching this video straight away as it's just come out, then that video will only come on like maybe a few days later. So subscribe then to get a notification, or otherwise just come check on the channel a little bit later. But otherwise, that's all I want to say. Thanks so much for watching, and I will see you guys soon. Hope you have a Merry Christmas, as it's almost Christmas season now. Cheers.